Hello dear students, lecture number 2, chapter number 25, determination of a capacitance of a parallel plate capacitor. So how to determine the capacitance, how to derive the formula of a capacitance of a parallel plate capacitor. So before going to this, so I have to explain there are different types of capacitor. So simple capacitor is parallel plate capacitor, the capacitor that has simple two plates that are parallel to one another. The other one is spherical capacitor. Spherical, it has two spheres that are separated by distance. Similarly, we have cylindrical capacitor. So first we explain about the parallel plate capacitor, how to determine the capacitance of a parallel plate capacitor actually. So parallel plate capacitor, so that we have two plates that are parallel to one another. When you connect to the battery, so the one plate stores positive charge, other plate stores a negative charge. So suppose on the left side the positive charge is stored on the plate B, and on plate A the negative charge is stored on the A, so that the area of the both plates are A, that is represented by A, and the gap between the space between the plates is represented by the D. So area A is the basically area of plates, and D is the separation between the separation between plates. Okay, now we determine the capacitance or ability for capacitor. Okay, so in order to determine the ability or capacitance of a capacitor, so we start from the Gauss's law. So the Gauss's law says that the one of the application of the Gauss's law is that the electric field intensity developed between the plates, that is represented by sigma over epsilon naught. So sigma is basically surface charge density, that is the charge per unit area, charge q per unit area A. So sigma is charge per unit area A. So this is equation number 2. So we use two equations, E is equal to sigma over epsilon naught and sigma is equal to charge per unit area A. Okay, so if I put this value of sigma in equation 1, put value of 2 in equation 1, then intensity E is equal to sigma, instead of sigma we put Q over A in the equation 1. Instead of sigma we put equation Q over A. So A can be taken to the denominator, so E is equal to Q over epsilon naught A. Okay, so this is equation number 3. Okay, so if we want to find the potential, so now we use the relationship between electric field intensity and the electric potential from chapter number 24. That the relation is that the simple potential difference VBA is equal to minus integral E dot dl, that is from A to B. Line integral is from A to B. So in chapter number 24 discuss in detail the potential is equal to integral E dot dl, and now the VBA is equal to, now we put in value of the electric field intensity. Before putting that we just solve for E dot dl. So E dot dl is equal to E dl cos of 180. So how we introduce the cos 180, because we know that electric field intensity and the length element dl is at the angle of there is the angle, because we know that the line integral along the path anti-parallel to the field lines from the plate A to B. So because we know that the line integral from A to B, so the line integral is taken from A to B, dl is taken from A to B, but electric field intensity is from left to right, B to A. So the angle between, because these two vectors are anti-parallel, so when two vectors are anti-parallel, so electric field intensity is going rightward and dl length element is going leftward, so that angle between these two is 180 degree. So cos 180 makes minus 1, so that VBA is equal to minus A to B E dl into minus 1. That gives us A to B E into dl. This is dl. Okay, so this is VBA. Now we put the intensity formula that we introduced in the previous Q over epsilon naught A. So intensity E is equal to VBA is equal to intensity E is equal to Q over epsilon naught A and multiply with the dl. So Q over epsilon naught A integral A to B into dl. Okay, now we took the integral. So when we took the integral, so it give us the because we know that the this is Q over epsilon naught A and this is 1, and 1 integration of 1 is simply L upper limit and lower limit from A to B. So as we know that this is distance is d from A to B, B minus A, the distance is d. So Q over epsilon naught A, so that the distance B minus A, that gives us the distance between d. So this is VBA. Now we can find the capacitance because Q is equal to CV, and C is equal to Q by V. So if I rearrange this equation in such a way that I took Q over V, so Q over V gives us, so simple we rearrange this equation for the Q over V, that gives us capacity, that gives us the Q over VBA, that gives us Q over V epsilon naught A over D. So Q over V is the capacitance C, epsilon naught A over D. So this is the formula that we need. Capacitance C is equal to epsilon naught A over D. Okay, thank you.